Welcome back. Now we're going to go into IP Insights. But before we get started, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. IP Insights. So this is an unsupervised learning algorithm built for cybersecurity. It detects anomalous behavior in web traffic by learning normal patterns of IP address usage tied to entities like user IDs or account IDs, then flagging unexpected deviations. This makes it valuable for fraud detection, intrusion detection, and bot identification, all without requiring labeled training data. So, how does this work? The algorithm uses a neural network to map IP addresses and entity identifiers into a latent vector space, learning the relationships between them. It applies hashing to convert entities and IPs into integers, uses embedding layers to learn vector representations, then calculates distance metrics through dot products between vectors to score the likelihood of entity IP pairs. The critical feature is automatic negative sampling. The algorithm generates random entity IP pairings to simulate anomalies during training. This makes IP Insights particularly effective for unbalanced data sets where anomalies are rare, which is typical in security monitoring scenarios. So, IP Insights requires CSV formats exclusively. It might have changed though, but each row contains two columns, an entity and an IP address. The entity can be any identifier for the requester, like a user account, a session ID, or a device identifier. The IP address is the source of the activity you're monitoring. Validation data is optional since this is unsupervised learning, but providing it lets you compute evaluation metrics like area under the curve, also known as AUC, to assess model quality. So what we're going to do is configure this in the console. We're over here in AWS. We're going to go to SageMaker AI. You're going to get that CSV. Okay. You're going to drop it in your S3 bucket over here. And remember that. We're going to go down to training jobs, create training job. Select IP. Well, we're going to name it IP Insight Test. Select your IAM role. Select your built-in algorithm, which is chosen by default. And we're going to look for it here. IP Insights, anomaly detection. Okay. Then you'll see the metrics over here for CloudWatch. Select the instance type. So the best ones are going to be the GPU instances, like ml.p starts with the P3, right? So these are preferred because IP Insights is a neural network algorithm. CPU instances work for small or simple data sets, but they train significantly slower. So for inference, choose based on your priority. So the GPUs provide lower latency for real-time scoring, while CPUs would reduce costs if latency isn't critical. So balance your throughput against the budget constraints. All right. So we'll just say P3 8x large. All right. And then let's see the instance count, keep alive period. We'll just leave those the same. Oops. 60 minutes. All right. And 24 hours. You can select network isolation with the VPC, security groups, subnets. And then you're going to configure your parameters, which you were showing over here. All right. So there's main parameters here that you should go for. So one we're going to look at num entity vectors. Set this to roughly 20 to twice your set it to roughly twice the size of your unique entities, right? So this will determine how many entity vectors the model learns. Let's say 100. All right. Then your vector dim. All right. This controls the embedding dimensionality. Larger values create more expressive representations, but it could risk overfitting. So we'll go with the default 128. Then you're going to go for the epochs. So this is for the training iterations. We'll keep that at 10. Your learning rate. This will be for the optimization. We'll keep this here. Then you go for your batch size. So this is for training batch sizes. And then your shuffle type. All right. So this is for data shuffling strategy on the larger data sets. All right. And we'll keep this at the default here. And you can adjust these once you get a result or an output artifact and then get better parameters fitting. All right. Next, you're going to go for how you're going to input the data. So you'll see here the text CSV over here. Let's set that the pipe mode. No wrapper, no compression. You set the input where you put your CSV file, that S3 bucket. The checkpoint here for that S3, when you're using spot training to save costs, then your output S3. Then you're going to add your key value tags for your project, team, environment, contact, etc. And then you'll click training, click quick create training, and then you should be good. So once done, this will get you a strong IP anomaly detection system, right? Which means it'll be good at flagging suspicious login attempts from unfamiliar IPs, detecting compromised accounts through abnormal access patterns, monitoring bot traffic across your systems, and enhancing fraud detection by identifying unusual entity IP combinations. So these will be any scenario where you need to identify anomalous network behavior without pre-labeled examples. Okay. We're going to click cancel. All right. Okay. So how does this work with the rest of the AWS system? This integrates through security, right? S3 will store your training data and your artifacts. CloudWatch will monitor your endpoint metrics like latency and error rates. SageMaker pipelines can automate the retraining as new data accumulates. And then you can work with EventBridge and Lambda to trigger alerts when anomaly scores exceed your thresholds. This will enable an automated incident response. And then remember, SageMaker Studio and notebooks will support exploratory analysis, helping you to tune the hyperparameters and analyze anomaly patterns before deploying to production. Your next biggest concern is going to be cost. The costs are going to accumulate based on your instance hours multiplied by your instance type rate, right? So the inference costs depend on the endpoint runtime, and then the surcharges are going to be applied for, the charge is going to be applied for the S3 storage or EBS volumes attached, active SageMaker endpoints, and the GPU instances, which cost more than CPU, but they train faster. So you're going to calculate your total costs, including the compute time, the hourly rates, to determine the most economical approach. For the certification, remember a couple of essentials. IPInsights is unsupervised and designed for cybersecurity anomaly detection. The input format is CSV with entity IP address pairs only. The algorithm uses neural network embeddings and dot product similarity, right? It automatically generates negative samples during training. No labeled anomalies are required for training. GPU instances are strongly recommended for training efficiency. The output is anomaly scores, where lower values indicate more suspicious behavior. And common use cases include fraud detection, intrusion detection, and bot identification. So when the exam mentions questions about suspicious IP behavior, identifying compromised accounts, or unsupervised security monitoring, IPInsights will be your answer. So that will be all for this one. Thank you for joining. Remember to hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. Thank you. Have a good day.